Good morning, students. I am Chaitanya, Assistant Professor in Mathematics, Department of Mathematics, Institute of Aeronautical Engineering, Freshman Department, located at Dundigal, Hyderabad. We are going to take up one more interesting topic from the course Probability and Statistics from the Module 1, that is the conditional probability and the related properties. So, today's discussion topic is conditional probability. Let us see what is the definition of conditional probability and some examples of conditional probability, and we'll solve some problems related to conditional probability. So, before defining the conditional probability, let us discuss the difference between general probability, that is P of A, and the conditional probability P of A over B. That means after this definition, we'll see what is the difference of P of A and P of A by B. Both are aiming at happening of A. P of A means happening of A. P of A by B means is also happening of A, but underlying to some condition. So what is the difference and what motivated us to define this approach of conditional probability or resort to the approach of conditional? Let us discuss all these things, and then we'll see some problems based on conditional probability. First, I'd like to define what do we mean by conditional probability. If capital A and capital B are any two events of a sample space capital S related to the random experiment capital R, such that P of A not equals to 0, and also we can imagine as P of B not equals 0 for our convenience sake to define both A over B and B over A. So we can assume that P of A not equals 0 and P of B not equals to 0. If we recap, random experiment is nothing but an experiment whose results cannot be predicted in advance. That means tossing a coin, rolling a die, picking a card from a deck of cards, or selecting a ball from a box, etc., etc. Or every competitive situation turns to be a random experiment. And every random experiment will be associated with the set of all possibilities. If you list all the possibilities and gather it into a set is known as the sample space, and it is denoted by capital S. You know, the sample space associated with the random experiment tossing two coins at a time is HT, TH, TT, and HH. And the sample space associated with the experiment rolling a die is the numbers 1, 2, 3, 4, 5, 6. An event is nothing but any subset of the sample space capital S is known as an event. If you take an empty subset or a non-empty subset or the whole sample space, every subset of S is known as an event. In general, event represents the wish of a player involved in the game. That is, every player playing the game will have a wish, and the wish is known as event. Two players are said to be mutually exclusive. If A wins, B has to lose, and B wins, A has to. That means A and B cannot win simultaneously. That means A and B cannot happen simultaneously. Those events are called mutually exclusive. And A and B are called equally likely if P of A is equal to P of B. That is, both A and B have equal chances of winning. And classical definition says that P of A, that is probability of happening F A, is nothing but number of favorable cases of A over total number of cases of S. That is, the cardinality of A over the cardinality of S, where A is an event of S and S is the sample space related to the random experiment capital R. And axioms says that probability is always positive, and the sum of all probabilities will always be 1. And the probability of A union B will be probability of A plus probability of B, provided A, B's are mutually exclusive. In general, probability of A union B union C is equal to probability of A plus probability of B plus probability of C, provided that A, B's are mutually exclusive. And for non-mutual exclusive cases, we have additive law formula, that is P of A union B is equal to P of A plus P of B minus P of A intersection B. And if we analog it to three events, P of A and B and C is equal to P of A plus P of B minus plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. These are the required formulae and prerequisites to understand the concept of probability. Now we are going to define a new kind of probability called conditional probability. Let us consider two events A and B in a sample space capitalist such that both are non-zero, that both are having non-zero probability, that is P of A not equals 0 and P of B not equals 0. Then the probability of the conditional probability of B, given that A is already happened, that is under the condition that A is already happened, the probability of happening B, which is denoted by P of B by A, is defined as their common probability over A's probability. That is P of A in section B over P of A. So P of B by A is mathematically defined as P of A in section B over P of A. If you see Venn diagrams, two events A and B and sharing a common region A in section B, then P of B by A is nothing but the common area by the area of the circle represented by A. That is, the common area is called A in section B and the area of circle represented by A is called as circle A. So P of B by A is the common area by over the circle A, area of the circle A. So what do we mean by P of B by A in general? How could we interpret P of B over A in the general life? P of B by A gives us the probability that happening of B under the condition that A is already happened. If there are two events, namely B and A, we assume that A is already happened, then what would be the change in the probability of happening B? That means in our practical life, there may be situations that happening of one event may influence the happening of another event. In that case, what would be the change in the happening of latter event with the happening of the prior event? That is called the conditional probability. For an example, let us assume that a cricket team selection is being conducted in our college IARE. There are only two slots are left, that is opening batsman slots. And three players are contesting strongly for those opening batsman slots. So there are three players are contesting for two slots. So under general conditions, that means under no condition, that means without condition-free atmosphere, the probability of three players getting to be selected into the cricket team is equal. That is 1 by 3, 1 by 3, 1 by 3. All the three players have equal probability. That is 1 by 3, 1 by 3, 1 by 3. In a conditionless atmosphere. That is under no condition. Suddenly, our team selection committee has imposed a condition that one place is completely meant for left-hand batsmen. One place is completely left for left-hand batsmen. But among the three players, the player one is the only left-handed batsman and the remaining two are right-handed batsmen. Then automatically the player one has 100% of chance to be selected into the team and the probability of the other two players will be reduced to 25%. Originally they have shared 33.3% equal chances, but with the condition of one place is completely dedicated for left-hand batsmen, the first player's probability has been tripled and the remaining two players' probability has been halved. So that is called condition. When you impose a condition, the probability of winning may be reduced or may be increased. That is called conditional probability. So mathematically, P of A over B is defined as P of A in section B by P of B, and P of B over A is defined as P of B in section B by P of A. Now, independent events. Two events A and B are said to be independent if P of A over B is equals to P of A and P of B over A is equals to P of B. That is, the imposition of condition B doesn't show any effect. That is, the probability of happening of A under condition B or without the condition of B are same. P of A is equal to P of A over B means if you impose the condition B or if you withdraw the condition of B, doesn't show any effect. Both are same. Similarly, P of B over A is equal to P of B. That is, A is not at all showing any influence on B. That is, happening of B is completely independent of happening of A. So, two events A and B are said to be independent if P of A over B is equal to P of A and P of B over A is equal to P of B. And from these two equations, we can easily say that A and B are two independent events if P of A in section B is equal to P of A into P of B. That is, it is an alternative form of interpreting independent events. Two events A and B are called independent if P of A in section B is equal to P of A into P of B. That is, simultaneous happening of A and B, the probability will be equal to the product of probabilities of happening of A and happening of B. That is known as independent events. Now, the multiplication theorem for dependent events states that if A and B are two dependent events, then P of A in section B will be P of B into P of A by B or P of A into P of B by A, provided that P of A and P of B are non-zeros. So, multiplication theorem for dependent events states that the probability of simultaneous occurrence of A and B is nothing but product of P of A and P of B by A or product of P of B and P of A by B according to the evidence that available with us. In the case of independent events, automatically the multiplication theorem becomes P of A in section B is equal to product of individual probabilities, that is P of A into P of B. So there are two multiplication theorems knownly, multiplication theorem for dependent events and multiplication theorem for independent events. So dependent event states that P of A in section B will be P of A into P of B by A or P of B into P of A by B. But independent event states that P of A in section B will be P of A into P of B. These formula will help us to solve the problems. Let us see problems. So now we are going to see a problem on conditional probability, the basic definition of conditional probability. In this problem, the probability that a communication system will have a high fidelity is 0.81. Communication system means you can imagine as an ultra modern mobile, that is a smartphone, a branded smartphone like Samsung. The probability that a selected Samsung smartphone will have high fidelity, that means high long life, fidelity means long life, is 81%. That means Samsung mobiles brands are popular in fidelity as with 81% reliability. That means whenever you select brands in Samsung, out of which 81 brands are having long life, long sustenance. That is the track record of Samsung mobiles. Now, the second line states that the probability that a selected model of Samsung brand will have both high selectivity and high fidelity is 0.18. That means if you select a smartphone of Samsung brand, it will have two qualities of selectivity and fidelity is 0.18. What do we mean by selectivity and what do we mean by fidelity? Fidelity means long life. That means it will not become useless even though you throw it down for a number of times. It will be more strong in life as well as in the structure or material used. And selectivity means the popularity, that is features and the advancement and the operating system that is being installed in that mobile. So selectivity means popularity and fidelity means long life. The Samsung model which have both selectivity, that is both popular as well as long life, is only 18%. So basing on this, we are asked to find the probability that if we select a mobile, a system into our hand, which is known that it has high fidelity, then what is the probability that it will also have high selectivity? So this is a conditional probability. Let us see the solution of the problem. So If we name the fidelity as F and selectivity as SE, then P of F will be 81%, that is 0.81, and a system with both high selectivity and fidelity is F intersection SE, that is 18%. So Samsung mobiles have 81% fidelity and 18% both selectivity and fidelity. Now, our claim is, if you select a mobile into your hand and you know that it has high fidelity, that is, it has high long life, what is the probability that it will also have high selectivity? That is, it is popular in the public. Okay, that is the question. Now, the short formula says that the probability of conditional probability can be easily written with the help of this hook line, that is probability of latter happened event by the probability of first happened event, that is probability of selectivity over fidelity. Okay, selectivity over fidelity means P of A by B, that is P of A intersection B by P of B, that is SC intersection F by F, that is 18% by 81%, that is 22%. That is, if you select a mobile with high fidelity, then the probability of that it will also have high selectivity is 22%. With this conclusion, in a class of 40% of students, in a class, 40% of the students study math and science, and 60% of the students study math. What is the probability of student studying science? Known that he is studying science, what is the probability that he will also study math? That means in a class, 40% of the students will like both mathematics and science. That means 40% of the students are interested in doing both mathematics and science. And 60% of the students are interested in mathematics. Basing on these clues, we are asked to find, if we select a student at random and if know that the student is interested in science, he is very, very good in science, what is the probability that he is also good in mathematics? That means here two events are happening one after other. The event happened first is he is good in science, and the event is going to happen later is he is good in mathematics. So under the condition that he is good in science, we have to calculate the probability that he is also good in mathematics. So this is a conditional probability. Let us see how we are going to handle this problem. According to the data, if we denote the event of mathematics with M and the event of science with S, then the event of the percentage of students who are good in both mathematics and science are 40%. So P of M intersection is 0.40. And according to the data, the percentage of students who are interested in mathematics is 60%. Now, according to the question, it is known that the selected student is very good in science, and what is the probability that he is also very good in mathematics? So mathematics is happening later and science is happening earlier. So logic says that the latter happened over the event happened early over the event happened later. That is P of S by M. The event happened early over the event happened later. P of S by M is nothing but P of M intersection S over P of M. That is 40% by 60%. That is 2/3. That is 67% of chance that is also interested in mathematics. So in this way, we can find the conditional probabilities by using the definition of conditional probability, and we can conclude that the probability of a student who is already interested in science is also interested in mathematics is 67%. Another problem, the probability that a trainee will remain with the company is 60%. The probability that a trainee earns more than 10,000 rupees after successful completion of training is 50%. The probability that a trainee will remain with the company or he will earn an income more than rupees 10,000 in the same company is 70%. If a trainee is selected at random and found to be remained with the company, then determine the probability that he will earn more than 10,000 rupees. So, in this question, the probability that a trainee will remain with the company, that means a trainee is selected to a company, a person is selected to a company, and after undergoing training, he may leave the company or he may continue with the company. The probability that he may remain with the company is 60% even after training. And the probability that a trainee earns more than 10,000 after successful completion of training is 50%. That means in every two successful completion trainees, only one person will be able to earn more than 10,000. And the probability that the trainee will remain even after the company and or he earns income more than 10,000 is 70%. That means either the trainee will remain with the company or the trainee will earn more than 10,000 rupees is 70%. With the details, we are asked to find a probability that the selected trainee at random will found to be remain with the company. Then we have to determine probably that he will earn more than 10,000 rupees. Let us look into the solution. Let us denote the event A denotes a trainee will remain with the company, and event B denotes a trainee will earn more than 10,000 rupees as income per month. Then, according to the data, the probability of a trainee will remaining with the company, that is P of A, is 60%, and the probability that a trainee will earn more than 10,000 rupees is 50%, that is P of B is 50%. And the probability that either a trainee will remain with the company or a trainee will earn more than 10,000 rupees, that is A in and B, is 70%. We are asked to find that a trainee who remains with the company will also earn more than 10,000 rupees, that is P of B over A. So, according to the definition of conditional probability, P of B over A is nothing but P of A in section B over P of A, that is additive law. P of A in section B can be written as P of A plus P of B minus P of A in and B over P of A. The additive law of two events states that P of A in section P in and B is equal to P of A plus P of B minus P of A in section B. So, P of A in section B can be written as P of A plus P of B minus P of A in and B over P of A. From the data, P of A is 60% and P of B is 50% and P of A in and B is 70%, and hence the numerator becomes 40% and the denominator is 60%. Finally, the answer is 67%. That means a selected employee who is known to be remaining with company is also earn more than 10,000 rupees per month is 67%. Okay. That means originally the 50%, but it is raised to 67% when the condition A is imposed on B. So P of B is 50%, but after condition A, P of B is raised to 67%. So condition makes a change in the original probability. That's what we understood from this. So with this problem, I'd like to conclude this lecture and we'll meet with an interesting topic in another lesson. In this lesson, we have discussed what is the meaning of conditional probability, what is the formula of conditional probability, and what is the multiplicative law associated with the conditional probability, or dependent events, independent events, and the problems related to the conditional probability. And in the next lesson, we'll meet with an interesting topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.